Today we are going to practice our implicit differentiation by differentiating e to the x over y equals x minus y. So what we're going to do is we're going to take the derivative of both sides. So we're going to differentiate e to the x over y with respect to x, x over y. And then we're going to differentiate x with respect to x and y with respect to x, and that's actually going to make that dy over dx, which is our slope of the tangent line. We're going to solve for that, but there's going to be two of those. So we're going to need to get those on one side, everything else on the other side, and then solve for it. This problem is algebra heavy, and what actually can mess you up is the algebra. The differentiation itself isn't that hard. So for example, the first thing that we're going to differentiate is this right here. Well, let's make a little side note. Let's do some side work here. Side work. Let's just take this corner just for the derivative of e to the x over y, because this is a composite function. The outside function is e to the x, and the inside function is x over y. So this is actually going to be e to the x over y, because the derivative of e to the x is just e to the x, and the inner function is x over y. So we plug the inner function into the variable in the derived outer function, and then we multiply that by d by dx of x over y, because that's the inner function. Now, we're going to need to use the quotient rule here. Quotient rule. So what we're going to do is we're going to just write it out step by step. So that's a multiplication right there. That is going to be y times x prime minus x times y prime all over y squared. Now that is going to equal, let's put our equal sign there. That is going to equal e times x to the y times y minus x times dy over dx. And this is where our second dy over dx is going to be, all over y squared. So that entire thing is our derivative of e to the x over y. Now, it's pretty clear that that's the side work. Okay, so let me just change colors so we don't get confused. So now we're going to plug that in. So we're going to end up with e times x over y, e to the x over y, times y minus x times dy over dx, all over y squared, equals, I don't think that I accidentally didn't write the x here, but there's an x there. So then the derivative of x with respect to x is just 1. So we're going to have 1 minus dy over dx. So we're solving for these two right here. That is the slope of the tangent line. Dy over dx is the slope of the tangent line. So we're going to multiply both sides by y squared and end up with e to the x over y times y minus x times dy over dx equals y squared minus y squared times dy over dx. Then we're going to multiply this argument by e to the x over y. So we're going to end up with y e to the x over y minus x e to the x over y times dy over dx equals y squared minus y squared times dy over dx. So now let's let's call to mind what we're trying to do. We are trying to get dy over dx over to the left side. It could be the right side. It doesn't really matter, but the left side is easier. So we're trying to get this right here and this right here on one side. And we're trying to get this right here and this right here on the other side. So I'm going to choose another color and I'm going to write negative x e to the x over y times dy over dx. So that's this right here. And then I'm going to add y squared times dy over dx to both sides. And I'm going to end up with plus y squared times dy over dx equals, and now I'm going to subtract y times e to the x over y, this right here. I'm going to subtract that. So we're actually going to end up with y squared minus y times e to the x over y. Okay, so now we've got them on one side, but they aren't alone. We can't solve for them yet. So we're going to factor them out by grouping. And this is going to become dy over dx times negative x e to the x over y plus y squared equals y squared minus y times e to the x over y. And now we're just going to divide by this entire argument right here. Just going to divide by that. And then we're going to have our derivative. So let me see, what color do I want? So then we're going to go up here and we're going to write down dy over dx is going to equal y squared minus y times e to the x over y all over negative x e to the x over y plus y squared. So this is the solution, but we want to simplify this a little bit more. We're going to factor out one y on top. We're going to factor out the negative. Actually, no, the negative is factored out. We're just gonna rearrange these so that it doesn't have a negative in the front. That just doesn't look nice. That's all. Okay, so we're going to have y times y minus e to the x over y over y squared minus x e to the x over y. And that is our derivative.